Okay, now we have 5.3, the substitution method of solving simultaneous equations. Before we even begin to solve using the substitution method, let's just see what we mean by simultaneous equations. In this case, we have a pair of simultaneous equations, x plus 3y equals to 8, x plus 5y equals to 13. Basically, what we're attempting to do here is to solve these two equations, okay, to find, okay, a value of x and a value of y, okay, that will satisfy both equations. So basically, when we say we are solving simultaneous equations, we're trying to find value, or in the future values, okay, of x and y that will satisfy both of the equations that we're trying to solve. Okay, now let's begin first, okay, and then in the very first step in simultaneous equations is we label it equation 1, equation 2. Okay, the substitution method that we are looking at today means I'm trying to find a way to substitute away one variable. Notice x plus 3y equals to 8, you can't solve for x or y. Same thing here, x plus 5, 2x plus 5y is 13, got x, then there's y as well. We can't solve it. So what we can do here is this. First I say from 1. Okay, from equation 1, I start with x plus 3y is equals to 8. Then I know that x is equals to 8 minus 3y. Notice what I've done here is I've made x the subject of the formula. Okay, now that since we have rearranged it is something new, we call it equation 3. Now, where can equation 3 go? Equation 3 came from equation 1. I should not substitute it back into equation 1. That's pointless because they're actually basically the same equation. So equation 3 can now be substituted into equation 2. So in this case, I'll say I sub equation 3 into equation 2 like this. So where do I sub? Basically, I'll just look for everywhere that there is a x value. So in this case, there's a x value here, there's x value here, correct? So all the x will be replaced, or all the x will be substituted, okay, by 8 minus 3y. So here's x, so we get 8 minus 3y plus 5y is equals to 13. So we expand the brackets. Okay, negative 6y plus 5y is negative y. 16. 13 minus 16, okay, is negative 3. To solve this, I multiply by negative 1 on both sides of my equation. I get y equals to 3. But notice that our original mission is to find a value of x and of y. So far, we only have found y. Where can we find x? We substitute it back right into one of our original equations. Okay, you can just put it back here to try to find x into here, or here is fine as well. This is the most convenient because x is already the subject of the formula. So I will put it back into equation 3. X equals to 8 minus 3 times y, which is 3. So x is equals to 8 minus 9, x equals to negative 1. So therefore my solution is when y equals to 3, x equals to negative 1. And you have solved this problem. Okay, so x is negative 1, y is equals to 3. But now I just want to show you that this really works. Okay, let's try. Okay, see the calculator. X is negative 1, y is 3. Let's try and key it to see if these pair of values satisfies this equation. So put x is negative 1, then y is 3 times 3. Okay, I press my equal sign. 8. Indeed, okay, this pair of values, okay, will satisfy the first equation. Let's try to see if it satisfies the second equation as well. 2 times x, x is negative 1, plus 5y, y is 3, like this. Let's try to see. The answer is 13. Indeed, so these pair of values, x and y will satisfy both equation 1 and equation 2. So that's what it means by solving simultaneous equations. Okay, let me give you another 2 more examples, okay, on solving simultaneous equations. Alright, now example 2. Okay, example 2 will be solve the x plus 2y is equals to 12 and 3x minus y is equals to 1. Equation 1, equation 2. We can always start from equation 1, but I just want to mix things up to show you how we can solve with equation 2 as well. So I start from equation 2. I get 3x minus y is equals to 1. I do some algebraic manipulation. 3x minus 1 is equals to y. Negative y here, positive y there, so you get y equals to 3x minus 1. So notice I made y the subject of the formula. This is equation 3. Okay, if y is the subject of the formula, means I'll be trying to substitute away y later on. Okay, so now this is equation 3 came from equation 2, so I cannot take this and substitute back here because they are the same thing. So in this case, equation 3 should go into equation 1. So what I have here is this. I will substitute 3 into 1. So I have x plus 2. All the y will now be replaced by 3x minus 1. Then solving becomes simpler. We just expand. Then we get 7x is equals to 14. Dividing by 7 on both sides, x is equals to 2. Now we have to solve for y. Again, y can be taken from here. So y is equals to 3 times x is 2 minus 1. So y is equals to 5. So for this pair of equations, x is 2, y is 5 solution. If you try to plug it in here, you'll notice that when x is 2, y is 5. 2 plus 2 times 5, 10 is 12. 3x minus y, 3x, 3 times 2 is 6 minus y, which is 5. 6 minus 5 is 1. So this pair of values will satisfy both of these equations. Okay, I give you one final example for the substitution method. This one is a bit more difficult, but we will just hang in there. Okay, and it is this. 6x minus 2y is equals to 19, and we have 8x plus 5y is equals to 10. Okay, notice that when in the previous two questions, it was quite easy to find the subject of any one of them, okay, for x and for y. In this case, there is no x or y variable that has a coefficient of 1. So in this case, when we want to make the subject, right, x a subject or y a subject, it's going to come up to be a fraction in this case. But never mind. Okay, we will just try our best to see how it goes. So I go from 1. So I'll start right from 1. 6x minus 2y is equals to 19. Then we start 6x minus 19 is equals to 2y. So 2y is equals to 6x minus 19. Dividing both sides by 2, y is 6x minus 19 divided by 2. Okay, notice we have a fraction here. Okay, this is equation 3, but not to worry so much. What we'll do here is this. We'll sub equation 3 into equation 2. So what we have here is this. 8x plus 5. Notice that y is now replaced by 6x minus 19 over 2. So this will be 6x minus 19 over 2 is equals to 10. Now in order to simplify this whole equation, okay, what I can do is multiply everything by 2. Okay, so 2 times 8x gives me 16 over x. 2 and 2, if you multiply this whole term, okay, by 2, 2 and 2 will eliminate, so I'm left with 5 times 6x minus 19. 10 times 2 is 20. So what I get is 16x plus 30x minus 19 times 5 is 95 equals to 20. So what we get is 46x is equals to 115. Then dividing both sides by 46, 115 divided by 46 gives me 2.5. Then don't forget that we have to have a pair of solutions. So we have x is 2.5. So y we can work from here is 6 times 2.5 minus 19 over 2. Just key all of this into your calculator. You get the y value is equals to -2. So when x is 2.5, y is equals to -2. And these conclude my examples for chapter 5.3. Okay, stay tuned for 5.4, the elimination method.